Hey guys, welcome to your first algebra lesson here. As I mentioned in the intro, you guys today are going to take a look at Chapter R. Chapter R in your text, if you guys are just using the e-text, you may want to just make a note of it in your notes so that you can go back and reference it later after you watch this video. And that is page 1 in your text is what we're looking at here. So just the very first chapter, again called Chapter R because it stands for Review of Prerequisites. Even though the author of this textbook looks at these as prerequisites, meaning that these are things you should know before starting college algebra, I'm going to teach them as if they're brand new because I know all of us have had different math experiences because we all have gone to different schools, whether it's high school or previous college. Some of these are things that maybe we've seen before, and for some of us these might be brand new. So I want to make sure that, better safe than sorry, I want to make sure that we teach them as if they're brand new. I will do a little bit of skipping around in this chapter, but I just want to start with what I think are the essentials for what you guys need to know in college algebra and the things that will help you in the rest of this lecture. Or not just this lecture, I'm sorry, but for the rest of the quarter. So I'm actually moving on to page 2. I want to identify numbers. On page 2, if you, again, we're referencing this for later, it talks about just different types of numbers. We have natural numbers, which is pretty much just every whole number absent 0. Whole numbers are numbers that do not include decimals or fractions or anything of that nature. But then there's integers, and that's what I really want to focus on this first part of the lecture. We're looking at, and I'll just go ahead and identify that for us, we're looking at integers. So you all will notice throughout the rest of the quarter that your teacher has terrible handwriting, but I apologize for that, so hopefully we can get through that. But in this section, we're just looking at integers, and integers includes whole numbers that are all positive, and really whole numbers and decimals. You may see them sometimes as decimals, but it includes really all numbers, but including all positive and negative numbers. If you guys have ever seen a number line before, which shows us how our numbers fall in counting order, if I look, right here in the middle, if 0 was in the middle, we would count, 1, 2, 3, 4, 5, 6, and so on and so forth. I could obviously go on forever, but we're going to stop there at 6. If I go to the left of 0 on the number line, we're looking at now negative integers. So it would count the same pattern, but we're going in just the opposite direction here, looking at now -1, -2, -3, -4, -5, and once again I could go on forever, but I'm going to go ahead and just stop there at -5. In positive and negative numbers, a way to kind of relate these numbers to things that maybe we've seen before, I always kind of think of positive integers. I relate it to money is what I do, and I always think of positive integers, which is the ones you guys are seeing down here, as money that I have. What I mean by that, if say 6, that was the last number that I wrote up there, if I have $6 in my bank account, or if my bank account just says 6, that means that's what I have. I have $6 in my account. Whereas if my bank account says -6, and actually let's put that in red because we know that would be really bad. Not really bad, I should say. But -6, that means that that's money that I owe to the bank. I'm negative. I'm in the negatives. Again, I look at that then as what I owe. So throughout this section of the lecture, I may often refer to that as, again, negatives being something that I owe, and positives being something that I have. And what we're going to do in this section, I just want to make sure that we feel good with adding, subtracting, multiplying, and dividing our integers. You'll notice that all the positive integers that I wrote down here on the right side of the number line, notice that I don't have to put a plus sign in front of those to indicate that those are positive. You can if you want to, but even without that, whether I have +6 written or just 6, that indicates that it is a positive 6. But notice over here on the other side, that negative sign had to be written in front of that 6 in order for it to indicate that it was -6. And so anytime we want to make sure that we're showing it as negative, don't forget to write that minus sign in front of that. So just to understand those a little bit further, I want to go ahead and calculate or look at operations with our integers. So I'm going to start with addition. So starting here with just addition. And as I go through these, may just talk about some of the different rules. Addition actually has two different rules. Let me give you some examples here. So let's say I'm adding together positive 4 plus positive 6. So this hopefully is an easy one. This is just a basic math problem here. We're looking at just 4 plus 6. We know that that's 10. Well, another way that we can look at this, because again, without that plus sign in front of it, that indicates that is positive 4, and this is indicated as positive 6, and our answer we noticed was positive 10. So that shows us that when we're adding two positives together, we ended up with a negative. So we just kept the sign. Another way that we can look at that, again thinking of what we owe and what we have, in both cases this is positive, so it's what I have. So if I have $4, say, in one pocket, and if I have $6 in maybe another pocket, then that means I have a total, and that's what we're doing, is we're finding the total by adding that together. I have a total of $10. Okay, so that's pretty easy. We know that basic, math question there, that 4 plus 6 is 10. But given the same scenario, but let's say instead I'm looking at negative integers. Let's say instead it was negative 4 plus negative 6. Some of you guys might be thinking, oh, I don't know. But some of you guys might be thinking, oh, well, that's just negative 10. Very similar to what we did in the previous problem, and that would be true. That anytime we're adding together a negative plus a negative, and that's what we did here, we ended up with a negative answer. A way that we can also think about that, again, negative integers indicating something that I owe. If I owe $4 for something, and maybe I owe a total of $6 for something else. So say I'm going to buy two things at the store, I owe $4 for one of those items, and I owe $6 for another one. When my cashier totals up what I owe, she's going to tell me that I owe $10, and that's exactly why we ended up getting that. So I mentioned at the very beginning, right before I started this, that addition actually has two rules. As we're maybe making our notes here, addition does have two rules. The first rule is what we just looked at in those two examples. That rule number 1 says when we're adding integers of the same sign, so in addition, if they're the same sign, then what we're going to do is we're simply just going to add them together and keep the sign. So just short and sweet here, I'm going to just put add together, and I'll abbreviate that. Add to get, add together there, and then we are just going to keep the sign. So anytime we have the same, again, two numbers with the same integer, so if they're both positive or if they're both negative, then we would just add them together and keep that sign. So we just saw 4 plus 6, but if I had negative 3 plus negative 10, then that would then in turn be negative 13. If I had 8 plus 12, then I know 8 plus 12, that's positive 8 plus positive 12, so therefore that would be positive 20. We're just adding them together and keeping the sign. So that kind of takes us back to basic math. So we know that, when we're adding two integers, that's how we always have added. Now, what's going to be a little bit different is when we're adding two integers of the opposite sign. So that's the second rule for, I'm just going to write opposite. When they're opposite signs, that's going to be our second rule for addition here. And let me give you an example to better explain this before I write out that rule. If, let's say instead, I'm going back to the 4 and the 6. Let's say it was negative 4 plus positive 6. So now you can see that the signs are different. So the first integer is negative, the second one is positive. So let's think back to our money scenario. Some of you guys may be already telling this your answer to yourself, and that's great if you know it. But this is, again, money scenario says that in this case I owe $4 since that's a negative. Positive 6 indicates that that's what I have. So let's think about this scenario. If I owe $4 for something and I have 6, what am I leaving that store with? Let's think. I had $6 in my pocket. I bought something that was $4. I leave that store still having $2. So my answer here is positive 2. In the reverse scenario, let's say it was positive 6 plus negative 4, positive 4 plus negative 6. So the exact reverse of that previous problem. In this case, and I want to put them on the same screen, so I didn't erase that there, but I'm getting a little short on room here. But in this case, 4 is what we have. -6 shows that that's what I owe. So in this scenario, I only have $4 in my pocket, but I'm trying to purchase something that's $6. I owe $6 for it. In that case, the cashier is going to tell me that you still owe $2. So that's where that -2 comes in. So a way that we can actually think about that without really having to think about money that I owe and money that I have every single time, what you could do is tell yourself this. Anytime we have opposite signs, what we're technically doing is we are subtracting their values. So we're going to subtract, and I'm just going to write their values. So meaning not including, so we're going to get into absolute value in just a little bit, but values meaning that I'm not looking at their positive and negative signs at all. So in both of these examples, I'm just saying the difference between 6 and 4 would be 2. So that's where the 2 came from in both of my answers. So we simply just subtract their values, and what that we're going to do as far as the sign of our answer, we're going to keep the sign of the larger value, So in both of my examples, even though 6 was positive in the first question and then negative in the second question, notice that the answer is the same sign as the 6. And that's because in both of these cases, 6 is bigger than 4, and so we kept the sign of that 6. So that's what we'll do every single time, is we're going to, anytime we have opposite signs, and if thinking of it as money that we owe and money that we have is easier for you, then definitely still do that. But think about that every single time, is that anytime we have opposite signs, I'm simply going to take the difference between the two numbers. No matter which one comes first, I'm taking the difference between the two numbers. And then I'm going to keep the sign of the larger number. All right, so let me give you another example. So let's say we have, say, -14 plus +5. -14 plus +5. So again, our rule says that we're going to subtract the values. So 14 minus 5 would be 9. I know it says plus, but what we're doing is, again, what happens when they're opposite signs, we're going to take the difference between their two values. So again, that's where the 9 comes in. And then we're always going to keep the sign of the larger value. So because 14 was my larger value in this case, 14 is bigger than 5. Since it was negative, so is my 9. There's my answer, -9. And again, if you want to think of it in terms of money, look at it as, well, I owe $14 and I only have 5. So therefore, I still owe another 9. And that's how we're going to look at that. Looking at another example, because I know this rule's a little bit trickier than what we were seeing before. If I say, let's say we have, oops, I need my pen back. Let's say we have -8 plus positive, let's say 19. Positive 19. So in this case, again, we're always going to take the difference between the two values. 19 minus 8 would be 11. And because the larger value of the two, 19 and 8, 19 is my bigger value, and it was positive, so is my 11. So there's my answer there, just positive 11. And again, looking at it as money, if I owe $8 and I have 19 in my pocket, then I can pay for that item and I will leave that store still having $11 in my pocket there. So don't forget that with addition. When we're adding two integers, don't forget to take a look at their signs before you do anything. If they're the same sign, then we're going to keep them, again, we're going to add it like we normally do. Just go ahead and add those two numbers together and keep the sign. So that, again, as a reminder, -5 plus -2 would be -7. We're just adding those two numbers together and we're keeping the sign. Whereas then when you have the opposite sign, like we did down here at the bottom, we're looking at the difference between their two values. So we need to take the difference between those two values and then keep the sign of the larger value. So I hope that helps with that addition. Okay, then we get into subtraction. So subtraction, only one rule for subtraction. And I want to, before I, write the rule down for, and I'll just write subtract, because I'm lazy. But with subtraction, what we want to look at here is this scenario before I put the rule down. So let's say this. Let's say we have -4. So again, thinking of the scenario in terms of money, I owe $4 to the bank. That's what my bank account says. And let's say I want to subtract 6. Now this is a little bit different than what we saw earlier. I'm not totaling this together now. What I'm looking at is I owe $4 to the bank, but that subtraction indicates that I'm trying to withdraw $6 that I think I have. If you think about it, what happens when your bank account is in the negative and then you go and take out more money? And no, not thinking about any withdrawal fees or anything like that, or overdraft fees. Just thinking about what happens to the account now. I had -4 and now I've taken out $6 more. Well, now I'm going to go even deeper into the negative. I'm now further into negative. I've now put my account at -10. So now I owe the bank $10 instead because I don't have that money. So that's, again, what we would get on that one. I want to show you there's a slight difference than what happens when we do this. Let's say I have -4 minus now -6. This is a little bit different. So now, once again, I owe $4 to the bank. But with this subtraction, now I'm subtracting a negative, which in a banking scenario, I like to think about this as the bank is taking away, so that's the subtraction, so taking away money that you originally owed. So oftentimes my bank does this. They forgive me of ATM fees. So let's say there was an ATM fee of $6 that you at one point had to pay. In this case, this is your bank account right now, and right now your bank is taking away that ATM fee. So in other words, what it's doing is it's taking it away, that fee, and it's putting it back into your account. So now your account goes up to $2. And so that, I think, to me, subtraction can sometimes be a little bit trickier when we think about it in terms of and what we have. So with subtraction, the easiest thing to really remember is what we're going to do, and it sounds kind of crazy at first, but it works every single time. I always remember the phrase, add the opposite. Anytime you see a subtraction problem, no matter what the subtraction problem looks like, you can apply this saying right here, and it says to add the opposite. And what that means is we are going to take that subtraction, and I'm going to do it on the top problem first. I'm going to change the subtraction into addition, and then in order for me to do that, and that's what I've done there in green, I'm changing it to addition, and then I'm going to take that second integer and turn it into its opposite. So the opposite of -6 would be +6. And so now what we're looking at, now we have an addition problem. So we just simply have to go back to our addition rules. And because that problem up there at the top, we have a negative plus a positive. Think about the opposite sign rule. That says we take the difference between those two values and we keep the sign of the larger value. And that's where that 2 came from. So that's why we were correct on that first one. Doing the same thing to that second problem down there. I'm going to change that to the subtraction to addition. That's what I did with the problem. The opposite of +6 that we had before would then be -6. And now again, we're looking at this as an addition problem. And so we're thinking about that rule. Here's a negative plus a negative. So my rule for the same sign says to go ahead and add them together and keep the sign. And that's where that negative came from. So for subtraction, you can, again, always remember the phrase, add the opposite. I had somebody in class one time tell me that she always remembered add a line, change the sign. If that helps too, that is totally cool. If you have, say, 6 minus -3. 6 minus -3, again, this is your bank forgiving you of a debt, so they're putting that back into your account. So we can add a line, change the sign, or again, remember, add the opposite, change that to addition, change that -3 to +3. Now I have +6 plus +3, which would be +9. Very good, all right. If I have, let's say, how about -3 minus, let's say 8, then again, -3 minus 8, that's money that I owe, and I am taking away $8 more out of my account. So what's happening here, if I add the opposite, I can change that to addition, change that +8 to -8, and you always change the second number, guys. You never change the first one, as you notice that I'm doing in all of these. It's add a line, change the sign, or add the opposite, and that opposite is always just applied to the second integer of the problem, so in this case the 8. And so now that we have this addition problem here, I'm going to look at that as such, and I'm adding two integers, it looks like, with the same sign now. So -3 plus -8 would be -11, because we're keeping that sign. Okay, doing one more for example purposes. You'll see some more examples in the review video too. But let's say we have, let's say, -4 minus -10. Okay, so right now, subtracting a negative, so I'm going to go ahead and add a line, change the sign. I'm going to add that line to make that addition, change -10 to +10. Now that it's an addition problem, I need to look at it as an addition problem. Looking at my two integers, I do have opposite signs, negative plus positive, so I'm going to again take the difference between those two values to get 6. Oops, wrong pen there. To get 6, there you guys can see that. And because my larger value was 10, it was positive, so is my 6. So there we go with that subtraction. And that's our rule for subtraction. Multiplication is a lot simpler. Multiplication and division both have the same rule. So just helping you guys out with your notes on here, I'm just going to write mult and div here for multiplication and division, and they have the same two rules. And that says this, that if we're adding two integers, if we're multiplying or dividing two integers of the same sign, as long as they're the same sign, your answer will always be positive, no matter what. So if I had like 6 times 2, since that's a +6 times a +2, my answer is just 12. Your answer will always be the same. Not like addition, where when the signs were different, it affected what the answer was going to be. In this case, your multiplication of 6 times 12 or 6 times 2 will always be 12, but the sign is just going to be the sign of your answer is going to be dependent on this rule. So again, same sign. If I had -6 times -2, on the other hand, I am still going to get +12, because again, they are the same sign, even though they're both negative. And sometimes that's tricky because we get that confused sometimes with addition, that if we were adding -6 plus -2, we would get -8. We would keep that negative sign. But here, when we're multiplying the same sign, my answer is always positive. The other rule says that if they're opposite signs, you guys probably, I combined what I was saying here, sorry. If they're opposite signs, opposite sign on the other hand, your answer is going to be then negative. So kind of going with what we had up there at the top, if I then have -6 times +2, so a negative times a positive, therefore my answer will then be -12 instead. And even if it was reversed, if it was +6 times -2, same thing. They're still opposite signs, so I'm getting -12. So again, in all of these problems, you notice that the answer was always 12. So 6 times 2 will always be 12. But when they're the same sign, when 6 and 2 are both the same sign, so there they were both positive. The second one, they were both negative. But in both cases, they were both the same, so that's why our answer was +12. In the ones down at the bottom, they were opposite signs. So one's a negative, one's a positive. That's where we get -12. One's a positive, one's a negative. There's where we get -12. And that rule applies for both multiplication and division. Anytime we see that, keep that in mind. So if I had, say, so same thing with division. If I said +20, and I'll just write this as a fraction line there, but that's division. 20 divided by 5, we know is always going to be 4. If I had -20 divided by -5, I'm still getting 4 on that one. But if I had -20 divided by +5, that's where -4 comes in. So look at it as if the signs are ever mismatched, that's where your answer becomes negative. So look at it that way. And that works and that's the same every single time across the board. If I had 5 times 7, that's always going to be 35. But negative 5 times positive 7, mismatched signs, negative 35 then. All right, guys, so I hope that helps with the multiplication and division. And those are your integers. So anytime, the quiz that you guys will see at the beginning of next week, when week 2 becomes available to you all, on that quiz, it will start with your integer questions. I will give you guys just 2 integers, and you guys just have to add, subtract, multiply, or divide those 2 integers. Okay, moving on. So that was the integers. The next thing I'm gonna actually skip over using inequality symbols. So we're gonna skip through that in your text. We're gonna skip through section 3 there too. I want to move on to absolute value. So absolute value is actually over on page 7. Again, if you're making notes in your text. What absolute value represents is, thinking back to our number line. I'm just going to draw a small one here. So just showing 1 through 3. So there's 1, 2, 3, how they fall in counting order. And again, I could go on, but then I'm going to draw on the other side -1, -2, and -3. So I could, go that way. What absolute value means, sometimes you'll see numbers written in these little brackets here, or if I said 3 with these 2 lines on it, and I want to know what that is, equals what? The absolute value, and that's what those little brackets are asking. This is asking for the absolute value of 3. The absolute value of any number is equal to its distance from 0 on the number line. So the absolute value of 3, here it is on the number line. If I were to count from 0, that would be 1, 2, 3 spaces away. So therefore the absolute value of 3 is just 3. Very similarly, if I asked you guys for the absolute value of -3 and wanted to know what that was, well, let's see. Absolute value of 3, I'm looking at this number down here. Well, let's count. It is 1, 2, 3 spaces away from 0 on the number line, and the answer would be 3. It's just equal to the number of spaces it is from 0. So an easier way to really think about absolute value is just that the absolute value of any number is strictly just that value without thinking of it in terms of positive or negative, because it represents the number of spaces. So it's just simply just that value. So if we were to think about that again, so therefore if I asked you guys then for the absolute value of, say, I don't know, let's say -47. Then if we were to actually count from 0 on the number line, how far away -47 is from 0, it would be 47 spaces. So therefore the absolute value of -47 is 47. The absolute value of 328 is 328. Okay, so hopefully that's not too bad. Just remembering that the absolute value of any number is simply just that number. You can also, what you'll also see is maybe if there are problems involving absolute value. So let's say I did this. Let's say I said, I want to know the absolute value, so there's what that line represents, of, say, let's say 5 plus -8, let's say, plus the absolute value of -7 minus -2, let's say. So let's think about this. So with this first problem, let's calculate that first problem right there using our integers. We know that 5 plus -8 would be -3, right? Because they're opposite signs. Our rule is to subtract their absolute values. Their values, and then keep the sign of the larger value. So yes, that would be -3. But again, we're looking for the absolute value of that answer. So the absolute value of -3, we know would just be 3. And then we're going to add that to what we get on the other side. So let's see what we get here. So we have -7 minus -2. Well, again, our rule for subtraction is to add the opposite. So -7 now plus +2 would be -5. But again, I want to know the absolute value of that number, and the absolute value would be 5. So we are simply just adding those two numbers together. The answer to this problem would be 8. You'll see some of those like this on your homework and on next week's quiz too. If I want to know the absolute value of something, keep that in mind. It's just that value. But even if it's the answer to a problem, don't let the fact that the answer to that problem is negative, like we had in both of these cases here, throw you off. The answer is negative, but the absolute value of that, again, representing the distance from 0 on the number line, the distance between 0 and -3 was 3. So that's all we're looking for on that. So that's all that's going to be part of that problem. The distance between -5 and 0 was 5. So that's all we're looking for on that problem. That's why we just ended up adding together 3 plus 5. All right, guys, I'm actually going to go ahead and stop there and just end this video with our integers and absolute value. So the video I know is titled Integers and Absolute Value because I just was covering this. I like to section the videos off, and you'll notice this throughout the quarter so that you guys can watch one video at a time and kind of take it at your own pace. You may have even chosen to watch half of this video if that's just what you had time for. But the next video will then move on to the next section when we get into our order of operations. So go ahead and move on to that when you get a chance.